Yo, yo, it's Mr. Woodworth, and we are going to review the lessons we've done in Chapter 4. And remember, it's a beautiful day for math. Let's go. Okay, Chapter 4 review. Let's start in Lesson 4.2. We skipped over 4.1, but Lesson 4.2 talked about relations, and that's simply a set of ordered pairs. So here's an example. Here's a set of ordered pairs. All right? In this specific relation, there's only 3 ordered pairs. There's other relations. We can even give equations for relations, like a linear equation or a quadratic equation, and they pair up. They have an infinite number of pairs. Okay, but the key is that it's a set of ordered pairs. Okay, there's special types of relations. One of those special types is a function, which we'll get to shortly. Okay, but we can break up relations into 2 different sets. All right, the domain is the set of x coordinates. All right, the set of x coordinates in a relation. Example, if you have this relation, right, there's your set of coordinate pairs or ordered pairs. And if you just take the x coordinates and put them in a list, that's your domain. Okay, so your domain for this relation is 2, 3, and 4. Now let's move on to the range, which is just the set of y coordinates in a relation. All right, so if we have this set of ordered pairs, all right, in our relation, then what is the range? Our range is 3, 10, and 5. 3, 10, 3, 5. I put in order, least to greatest. That's a nice way to list it. It's preferred. Okay, function. You can see this special word in here, fun, because it just brings so much joy to so many people. And we have a relation in which each member of the domain, so right, each of these guys here, 2, 3, and 4, all right, from this, right, each member of the domain is paired with exactly one member of the range. Okay, so let's do a little practice with functions here. All right, we'll test these relations. Here's a relation, here's another relation. We're going to make a mapping diagram to see if each member of the domain is only paired with one member from the range. Well, we're going to write our domain first. So domain, domain, and domain here. We only have to write them once. Right? We only want to write them once if they are repeated. So we see a domain value repeated here. So that's going to just be 2, even though it's written twice in our relation. And then we have a 3. All right, now we're going to fill in the range. We got the range of 3, 4, and 5. 3, 4, and 5. So let's see what they're paired with. The 2 is paired with a 3. But is that its only partner? No. Then that next point says 2 is paired with 4 as well. All right, now the 3 only has one partner. The 3 is only paired up with 5. But right here is what disqualifies this relation from being a function. All right, not a function. Now let's test this other one out. We have 1, 3, 2, 3, and 3, 3. In our domain, we have the numbers 1, 2, and 3. And it looks like our range is not varied very much. 3, 3, and 3. So we only have to write it once. Now let's see if the domain, each member of the domain only has one partner. 1 is partnered with 3, so it only has one partner. 2 is partnered with 3, it only has one partner. And 3 is partnered with 3, it only has one partner. So this is a function. Okay, now range values, you can use them as many times as you want. As many numbers can be paired up with that. But domain values have to be faithful to one number. Okay, I don't know what's up with 3 there in the range, but must be pretty hot stuff. All right. Now, we're getting into special types of functions. So we talked about what a function is. It's a special type of relation. Well, here's a special type of function called a linear function. We've talked about these for a couple chapters now. A function whose graph is a straight line. And what makes it straight? It has a constant rate of change, okay? So we have common forms of linear functions. We have slope-intercept form, which would be y equals mx plus b. And the m would be the slope, where the b would be the y-intercept, or where the line will cross the y-axis. We have standard form, which is ax plus by equals c. That's helpful. That's a helpful form when you're looking for intercepts to graph using the x and y intercepts. And point slope would be y minus y1 equals m times x minus x1. Okay, and that's a really helpful form when you are writing equations and you only have a little bit of information to go on. Okay, and we practiced that. Right? Remember, I gave you 2 points. You had to calculate the slope and then plug one of the points in, and you would get your equation for that relation. Okay, very important. Linear functions are characterized by a constant rate of change between coordinate pairs. Here we can see that the rate of change, remember rate of change, aka slope, all right, is the change in y over the change in x. Another way to say that is the rise over the run. All right, and what let's calculate the rise and run here. Okay, or the change in y over change in x. Change in y here is 3. Change in x is 1. All right, and look, you might say, wait, that's not constant. That's not the same, but watch what happens. 8 goes to 17. That's a difference of 9, and here's a difference of 3. So this was 3 and 1. This is 9 and 3. It looks like they're not the same, but it's a rate, remember. So we have to put them in a fraction, and that would be 9 over 3. And is 3 over 1 the same as 9 over 3? Of course. So this is a linear relationship because there's a constant rate of change. The fraction, when we make a fraction out of the changes, they simplify to be equal. All right? Okay, quadratic function. Now this was something very new to us. All right, being able to make a quadratic function, a function whose graph is a parabola or a U-shaped graph. All right, common form, we usually have y equals ax squared plus bx plus c. Now, we often did not have this bx term. That was often missing, and we just had the squared term and then another number. That's because it makes it easier for us to graph, being noobs at this whole graphing quadratics. Okay, so that was always missing. But this term here is very important. First of all, that little square there, that makes it a quadratic. Okay, you see there's no, in all these different forms of linear relations or linear functions, there's no x squared. You might say, yeah, there's no x squared. All the x's are to the first power, to the first power, to the first power. Okay, but here, what distinguishes this from a linear relationship, one of the things is that it has an x squared. Now, that makes this really important. When this number in front of the a is positive, we know our graph is going to open upward. All right. When that number there is negative, all right, we know that this graph is going to open, the parabola is going to open downward. It's going to be kind of an upside down U shape. Okay, that's when that coefficient of the squared term is positive or negative. That tells us which way our parabola is going to be facing. All right, our last page here, we have some practice graphing parabolas using a function table. All right, remember the numbers that we typically plug in? -2, -1, 0, 1, and 2. We simply put our rule here, -2, and we plug in everything. All right, this is very important to take your time and make sure that you're not rushing and making silly mistakes. All right, hopefully this will be a great reference for you for our test coming up, and you'll be able to use it and do pretty well. Okay, now I'm going to show you how I use order of operations over here. All right, -2 times -2 squared plus 5. Okay, I'm just solving or simplifying this one here using order of operations. All right, so there's nothing inside parentheses that I can simplify, but there are exponents here. So I'm going to bring this -2 down. Some of you were tempted to multiply these two first. Well, multiplication comes after exponent, so we have to do this exponent first. All right, -2 squared is going to be actually mean -2 times -2. This little power says use this number twice. Okay, so that's going to be +4, and we're going to add 5. All right, we did the exponent. Now we're going to do multiplication and division left to right. -2 times 4 is -8 plus 5. Okay, we're done the multiplication. There's no division. We're going to work on addition and subtraction. -8 plus 5 is -3. So when we plugged in -2, we got -3. The input was -2. The output was -3. Okay, now I'm going to do the next one. Just take your time, follow PEMDAS. All right, there's nothing inside parentheses to simplify, so we'll do exponents. We bring down that -2. It's multiplied because of that parenthesis there. Multiplied by -1 squared. -1 times -1 would be +1 plus 5. -2 times 1 is -2 plus 5. And -2 plus 5 is 3. There we go. All right. So we plugged in -1. We got out 3. -1 and 3. Now let's try this next one. I'm going to do it in my head. I'm going to do the exponent first. 0 squared is 0. 0 times -2 is 0 plus 5. All right, now we should, remember the symmetry, it should kind of go up to 5, then back down to -3. Let's just do the math in our head. Square, 1 times 1 is 1. 1 times -2 is -2. -2 plus 5 is 3, right? Same as this over here, -2 plus 5. And finally, we have 2 squared is 4. 4 times -2 is -8. -8 plus 5 is -3. We do have that symmetry. And now we're going to make our graph. Last little step here, hang in there. We are going to look at the numbers that we need to use from our y. Now, our x, we just have to go to -2 and to +2. So that's not going to challenge us too much. Okay. But we do have to go down to -3 and up to +5. So if I have 3 lines below, good, and 5 above, 1, 2, 3, 4, 5, good. I can fit my graph pretty nicely here. I'm trying to draw, oops, I'm going to go a little further. I'm going to try to draw this with as straight lines as possible. A ruler might help if you have one. I know I have to go up to +5. And I have to go down to -3. I try to make all my lines the same distance apart. Okay, so my graph doesn't get distorted at all. Okay, start with -2, -3. So that's going to be over 2, down 3. Try to line it up as best as I can. And down there. Then I'm going to go -1, 3. So that's going to go -1, 3. And I have 0, 5. 0, 5. All right. And then I've got my 1, 3. So that's 1, 3. And 2, -3. So that's going to be 2, -3. Try your best to get as much symmetry as you can. And then try to draw your curve as neatly as possible, drawing the arrows at the end. All right, there we have it. We have our parabola. We have our function table. Okay, pause and copy as much as you need to. And I hope that prepares you for your test coming up. Should be a good summary. Always a good day for math. Woodworth out.